Alright, collecting engineering data. Okay, so how do we collect engineering data? And actually, to be more accurate, how do you collect data? It doesn't really matter engineering data or not. Usually, it is the same. Now, what being shown here is actually the framework of statistical investigation, which involve the whole process. Alright, the process of collecting data is actually on the first two, where you formulate questions. Of course, in order for you to extract out the data that you want, right, you will need to ask. So, what is the problem? And based on that, formulate the question. And after you uh, clear on the questions, or you have a set of questionnaires, then you will go to the respondent, or maybe you will go to the subject or object, and then you will collect the data. Okay, so and after that you have the data, and then you can proceed with the other process. So what does it mean here is that you will need to really be careful in these two steps, right? Because yes, you can use any advanced mumbo jumbo method here in step 3 and 4. If this is not accurate, in statistics or in mathematics, we have these terms: rubbish in, rubbish out, meaning that it doesn't matter how good is your analysis. If your data is not accurate, then it will give you a biased result. Okay, so that's why it is important to know on how to collect data. However, we are not going to truly emphasize on how to collect the data. Right, we might need to have another session on how to discuss just on collecting data, if you have any time later. So to collect data, we are going to use a sampling methods, okay, where we are going to collect a sample. However, let's say uh, you your interest, right, is actually focusing on just a small group, right? Let's take an example. Let's say you want data of your class that is actually related to your class only, which involve maybe around 100%. So if it is possible for you to get all of those data, 100 data, then you don't need to use sampling method, because sampling method obviously is a method to choose a sample, right? To actually choose a sample of data. So if you're able to go for population, you don't need sampling methods, right? And that is actually the best. If you're able to get the whole data, it will be the best, right? Because when you conduct a sampling and when you give your decision based on a sample, there is a tendency for you to get an error. However, if you get the data for population, there is no error, right? So um, data should be collected correctly, as I said. If not, the conclusion will be meaningless. Random sampling. What is random sampling? It is a way of selecting sample where each individual in the population has equal chance to be included in the sample. Right? It is that it say here, when you want to, let's say you want to pick a data or a sample randomly, well, we need to make sure that all of the data has an equal chance to be included. As simple as, let's say you want to randomly choose your friends in the class as your sample, you'll need to make sure that all of them is within your view, right? So all of them will have an equal chance to be chosen, right? Still, I don't really believe in not choosing a sample using your senses, right? You have 5 senses, right? Eyes and things, because it can somehow be biased, right? Usually, when we conduct we want to conduct a random sampling, we'll just the most basic way is to just write down all of your names, put it in a bowl, and then I'll just pick it out randomly. So that is among the non-biased kind of random sampling. Okay, so and any kind of method can be used as long as all of the population has equal chance to be included in the sample. Okay, a sample of size n that is selected through random sampling from the population size n such that each possible sample. Okay, so as you can see here, first look at the notation. Sample size. This is the sample size. This is when the size is from sample, this is the notation small n. If the size of data is from population, it is a capital N. That is the notation. Okay, and this is a statistic. This is parameter. I just want you to make sure that you're clear with it. Okay, so if the data being retrieved from sample size, okay, randomly, it is called simple random sample. Okay, so that is about random sampling. Now let's look at the methods of sampling. There are two types of methods that can be used in this whole word. This is the two types, general types. So we have probability sampling and non-probability sampling, right? And of course, in statistics, we will go for probability sampling. Okay, so probability sampling involves selecting subject from the population in such a way that each subject of population has the same chance of being selected. That is the gist of probability sampling. Whatever methods that you use later, you'll need to make sure that it is all has the same chance to be selected, right? However, for non-probability sampling, this is usually the kind of sampling being done in non-statistical field or non-science field, right? They select a sample from population, but with an unequal chance. And that's by using non-probability method. There is a high possibility that you might not be chosen. Let's see one by one. So for probability sampling, we have simple random sample that we have already discussed just now. Simple random sample is you can have a way of simply put the names, all of the names in a bowl, and later you just pick it out randomly. Okay, that can be one way. And but currently we are not using that way anymore. We are using Excel at least, because let's say we want to talk about sample of the whole UNIMAP student. Of course, we need to have the name of all the UNIMAP students and put it in the computer, and we try to pick random student out of that list. Okay, and next we have systematic sampling, stratified sampling, and cluster sampling. Okay. These samplings, right, unlike simple random sampling, they actually we can't really actually just use one of these sampling methods to get a sample. This is usually just an extended version of simple random sample, right? We conduct systematic sampling first, and later simple random sampling. We conduct stratified first, and then we conduct simple random sampling. Usually we are going to end our sample selection by using simple random sampling. Right, this is just to organize the population a bit so that we are going to be able to get the random sample more equal. I mean, so that all of you really have an equal chance to be chosen. So next we have convenience sampling. For non-probability, we have convenience sampling, meaning you're just going to pick out everyone that you see. Right? This is usually being done in a shopping complex, where people are going to just, you know, they see, look at you, they see that you can approach you, then they go to you. So conveniently. So if you are somebody that, you know, have a kind of not no, they have a kind of bad feeling in on approaching you, they're not going to approach you. So which is, that is bias. Okay, the same goes for others. All of this will involve unequal chance to be chosen. So we're not going to use, you are not going to use non-probability sampling in engineering, because you are going to have a biased data and later we produce a biased result. Okay. So this is the kind of study that can be done in obtaining a data. We have observational study, which is by observing, right? Usually, this is being conducted in social science, where we can't really control the outcome of the data that will become. As example, as maybe you want to observe how many proton cars will go through the toll booth, that toll booth. So you're going to sit there and observe, right? So retrospective study, this is where a study is being made by using historical data set. And then design of experiment, this is what usually being done in engineering, where you can manipulate the variable, right? You can control the variable throughout the process, right? You do it in a lab. This is design of experiment. Okay, so next we have data summary and presentation. We're going to talk about it in our next video. Thank you.